All right, example 2. It says graph the function f of x equals x squared minus 4x minus 2. That's one function. And g of x equals negative x squared plus 2x plus 3 on the same coordinate system. So there's a coordinate system over there in xy axes. All right? They want us to graph both of these on the same coordinate system. Notice the structure of each of these is that quadratic structure. We have something x squared, something x, and a constant, something x squared, something x, and a constant. So we should be anticipating this parabola shape, that U-shaped thingy. And it's up to us to determine that. And again, this is that 5-step process I have written down there. So we're going to do that 5-step process for both functions. I'm going to do the first function, f of x. I'm going to do it all in red. So you see, all of that is in red, has to do with that. First thing I like to do again, I'm going to change f of x to the letter y. And x squared I'm going to write as 1x squared minus 4x minus 2. If anything happens to be missing, for example, if x isn't there, that's going to be 0x. B would equal 0 in that case. If it was just x squared minus 4x and there was no constant, that would be plus 0. So there's always, if there's a term missing, you put a 0 there. If the x squared is missing, now you're just looking at a line equation. So if x squared is in the problem, then it's important that there's 3 numbers there. But if there's no x squared, if it's just that, that's just a line function. Okay, we're not going to deal with those today.
Okay, so anytime that there's like 3 numbers in there, you put...
Yeah, anytime you see x squared, you should have it, something x squared is something x and constant. So if this 4x wasn't there, if it was just like that, x squared minus 2, you'd put plus 0x. So it would be 3 things. B would equal 0 in that scenario. But again, in this problem specifically, we have negative 4x. So I'm going to keep it as it was, negative 4x. So once we've written the problem down, again, this would be the first thing I do on my paper. That's written in the book. That's going to be written on my paper. All right? I'm going to identify the values of a, b, and c. A is equal to 1, b is equal to negative 4, and c is equal to negative 2. Step 1 is all about getting the vertex, the x-coordinate of the vertex. So that x-coordinate of my vertex is always a fraction, and that fraction is always the opposite of b, which b is negative 4, the opposite would be positive 4, over 2 times a, that's 2 times 1, which is 2. All right? If you can't do 2 times 1 in your head quickly, if you need to see it written on your paper, by all means write 2 times 1. There's no harm in writing it that way. But again, a is 1, all we write on the bottom is double that number. 2 times 1 is 2. That's where it's coming from. So if I divide that out, the x-coordinate of my vertex is 2. That's my most important value of x, and I'm going to use that to establish what other values of x I need to use. When we graph lines, we could have picked anything we wanted to. We're graphing parabolas. We have to pick this x value. Once I've established that, I'm going to do an extended xy chart. I'll show you what that looks like in a sec. First off, make the bar kind of long. I'm going to put x in this column. The vertical line is kind of to the left here. I've got my 2. I'm going to put it kind of in the middle here. And I'm going to go smaller and bigger. So less than 2, but close to 2 would be 1 and 0. Close to 2, but bigger to 2 would be 3 and 4. No matter what this number is here, make sure these numbers are always integers because they're easier to evaluate. We have to pick 2. The other numbers are our choice, but again, picking integers is easier than decimals. So sometimes this is a decimal. If this is a decimal, still pick integers for the other 4 points. The middle, I'm going to write down x squared minus 4x minus 2. And over here, I'm going to write y. Now, here's what I want you to see about evaluating these. And I don't know how good you guys are at evaluating things. Here's me. I want to make it as easy as I can for you possibly. So here's what I'm going to look at, and this is the way I want you to do it. Do a piece at a time. So x squared, this piece here, if I'm going to put those answers right here in this column. All x squared means is whatever x is, we take it to the second power. We square the numbers. What is 0 squared?
0.
What is 1 squared?
1.
2 squared?
4.
3 squared? 4 squared?
16.
That's all x squared is. Whatever x is, you square it. X squared is always positive. No matter if x is positive or negative, when you square it, you get a positive. Negative 2 squared is negative 2 times negative 2 is positive 4. So this column here should always be a positive number. The middle object, which is negative 4x, is going to come right down here. Negative 4x means that we take negative 4 times this and put the answer as an either addition or subtraction. So what's negative 4 times 0? So I'm going to put minus 0. Negative 4 times 1.
Negative
So I put minus 4. Negative 4 times 2.
4. Negative 8.
So I put negative 8. We see what's going on there. So it's just a numerical pattern happening here. Just each time negative 4 times the next x. Negative 4 times 3 is negative 12. Negative 4 times 4 is negative 16. So again, the x's establish the values of this column here based on what negative 4x evaluates to based on these x's. And then the final piece of this trinomial, this 3-term polynomial, is this minus 2, the constant term of negative 2. No matter what x equals, the answer is negative 2. So if x equals 0, the answer is negative 2. 1, negative 2. 2, negative 2. 3, negative 2. 4, negative 2. So you have a quadratic term that gets squared, a linear term is just a number times x, and then you have a constant term, just keep writing it down. And then you create just a simple little subtraction or addition problem here, you just evaluate each one of those. So 0 minus 0 minus 2 is negative 2, 1 minus 4 is negative 3, minus 2 is negative 5, 4 minus 8 is negative 4, minus 2 is negative 6, 9 minus 12, negative 3 minus 2 is negative 5, and 16 minus 16 is 0, minus 2 is negative 2. Now, a quick check before we put the points on the graph. If this is my vertex here, that's my vertex, 2, negative 6, right? If you have an integer vertex, you should have symmetry on either side. These are both 1 away, they're at the same height. These are both 2 away, they're at the same height. That should happen. If that's not an integer, if it's like 1.1, and this is 1 and that's 2, then it won't be symmetric. All right? But if it's integer stuff, you should expect symmetry. And while we're learning how to do this, it would be a good way to quick check your work as you go through. So I'm going to plot the 5 points. I got 0, negative 2, which would be right here. And I've got 1, negative 5, and 2, negative 6, and 3, negative 5, and 4, negative 2. The 5 points I got, notice their shape on the graph has that U shape that we're expecting for a parabola, because that's what this type of equation makes. So once we plot the 5 points, and again, x 0, y negative 2, x 1, y negative 5, x 2, y negative 6. So again, it's an extended chart, but I'm looking at the ordered pairs, x, y, to plot. So I'm going to connect those dots with my parabolic shape. I know that's my vertex lowest point to make sure that the graph turns around there. I continue on in both directions. There's my parabola. So f of x is graphed. It wants us to graph g of x on the same coordinate system. So I'm just going to real quick grab all this stuff. Maybe. Shrink it down just a little bit. I'm going to do g of x in green. So if we look at g of x, I'm going to write y equals, again, instead of writing a function notation like y equals when I'm graphing, I've got negative 1x squared plus 2 times x plus 3. And again, notice it's negative x squared in the problem. I wrote negative 1x squared. So again, I like to see numbers in front of my x squared and x so that I'm not getting confused with the whole a, b, and c thing. A is equal to negative 1, b is equal to positive 2, c is equal to positive 3. Again, the numbers I'm looking at with signs included. A is negative, b is positive, c is positive. The x-coordinate of my vertex for function g is going to be the opposite of positive 2, which is negative 2, over 2 times negative 1, which is negative 2. Negative 2 over negative 2 equals positive 1. So again, that's a real simple formula to use to figure out what the x-coordinate you have to use is. I'm going to make my extended chart, and this time I'm going to put the 1 on my equation. I'm going to show you why in a minute. But I've got negative 1x squared plus 2x plus 3, and I'm going to have y over here. So there's my extended xy chart. Again, the x and the y column, what is going to get me the information I need. The middle is just room to work out everything. All right. The x I have to pick is x equals 1, so I put that kind of in the middle. I pick two numbers smaller that are near 1, which would be 0 and negative 1. I pick two numbers bigger that are close, which would be 2 and 3 integers. And once again, let me just highlight this so there's no confusion. X squared, as I said over here, x squared is always positive. This is where I start looking like a little bit of a liar here, but x squared is always positive. I'm going to put x squared right here. Okay. Is negative 1 being squared? Negative 1 is being multiplied by x squared, right? Order of operation says powers happen before multiplication, right? So I'm going to just use a different color here for the negative 1. Erase that. The negative 1 right here. Negative 1 times x squared. So negative 1 times something, negative 1 times something, negative 1 times something, negative 1 times something, and negative 1 times something. The something that we're multiplying negative 1 by is x squared, and x squared is just the x list over here squared, and x squared is always positive. So when I do negative 1 squared, I'm going to get positive 1. When I do 0 squared, I get positive 0, which is really just 0. 1 squared is positive 1, 2 squared is positive 4, 3 squared is positive 9. So the x squared part of it's always positive, but then after the positive happens, we multiply by negative 1, which switches it to what? Negative. So when I see negative x squared, I'm going to get a negative result off of that because the negative happens after the squaring happens. No matter what x equals, x squared is positive, the negative takes effect after that. All right? And again, that's a place where a lot of people that begin to do these problems mess up. So I just want you to be cautious of that. Minus in front of x squared is positive, the minus switches it back to negative after you've already made it positive. All right, the next object is plus 2x. All right, so plus 2x just means plus 2 times x. So again, if we multiply these, we get a positive, we write plus that number, we get a negative, we write minus that number. So positive 2 times negative 1 makes negative 2. Hang on a second. Negative 2, there we go. Positive 2 times 0 is going to be plus 0. Positive 2 times 1 is going to be plus 2. Positive 2 times 2 is going to be plus 4. Positive 2 times 3 is going to be plus 6. And then we have our constant term, which is plus 3, which means everywhere along that is going to be plus 3. So plus 3, plus 3, plus 3, plus 3, plus 3. If you write a 3 bad, try and fix it, didn't look any better. I just did that. All right. So if we work it out, negative 1 minus 2 is negative 3 plus 3 is 0. 0 plus 0 is 0 plus 3 is 3. Negative 1 plus 2 is 1 plus 3 is 4. Negative 4 plus 4 is 0 plus 3 is 3. And negative 9 plus 6 is negative 3 plus 3 is 0. Notice, once again, here's my vertex. Here's my symmetry. Here's my symmetry. Again, I'm noticing symmetry. I should expect symmetry when I've got all integers for x. If you don't get symmetry, you evaluated something wrong. If there's a minus involved, it's probably this whole minus issue that I was talking about. So if I plot my 5 points, I got negative 1 comma 0, which is here, and 0 comma 3, which is right there, 1 comma 4, 2 comma 3, and 3 comma 0s. Negative 1 comma 0 will be here. 3 comma 0. All right. So negative 1, 0, 0, 3, 1, 4, 2, 3, and 3, 0. Once again, notice the parabola shape, this time an upside down parabola. Like so. The characteristic you can look for to make a decision before you even start what kind of parabola it's going to be, it's real simple. If, let me erase all this. If A is positive, the parabola is going to turn upwards. If A is negative, the parabola is going to turn downwards. That's if x is squared. Parabolas turn right and left when y is squared and x isn't.